Alright, so in this problem we have a scatter plot that shows the weight per 1,000 pounds as the explanatory variable and the fuel efficiency in miles per gallon. And then we have the summary statistics down here, and of course this down here next to intercept, let me zoom in on that, that's our y-intercept, and this is our slope, and that's our standard error, and there's our t-value, and there's our p-value. So we're going to do a hypothesis test here. Now, they said, is there strong evidence of an association? So that's a two-tailed test. So that's how we're going to approach this problem. So let's go through it. The parameter is big B, which is the linear relationship between weight of a car and fuel efficiency. Should be an I in here. Okay. And really this should be weight of a car. This should be per 1,000 pounds. And this should be in miles per gallon here. Okay. So our hypothesis, null hypothesis, is that big B equals 0. The alternative hypothesis is that big B does not equal 0. Okay, the assumptions. So we look at the scatter plot. So let's look at this. The scatter plot is straight enough. Okay. The residual plot shows no pattern. And then the histogram of the residuals is roughly unimodal and symmetric. And then each car's fuel efficiency and weight are independent. Okay, so we're going to put those down. So the scatter plot is straight enough. The residual plot shows no pattern. The histogram of the residuals is roughly unimodal and symmetric. And the independence assumption is each car's fuel efficiency is independent. Okay. Name the test. This is a Lin regression t-test. Okay, so our test statistics. So if I go here, I'm going to go through this. There's our y-intercept. There is our slope. Okay, there's our standard error. There's our t-value, and there is our p-value. Okay, so B sub 0 is 48.74, and I'll show you why I'm going to do this. We really don't need the y-intercept because we're not testing it. B sub 1 is negative 8.21. Standard error is 0.6738. Okay. N is 50, and degrees of freedom is 48. Okay, and I'm going to write the equation of this. So predicted miles per gallon is 48.74 minus 8.21 times weight in thousands of pounds. Okay. Sorry, didn't have that up, but there you go. Okay, so there's everything that we pretty much need. Now to obtain P, the t-value is going to be B sub 1, minus big B over the standard error. And if you do those out, guess what those come out to? Well, your T ratio is already given. It's negative 12.2. So this is a two-tailed test. Okay, so we would have T equals negative 12.2 and T equals positive 12.2. Now you see where it says here that the p-value right here is less than 0.0001. So our p-value, I'm just going to put down, is less than 0.0001. Okay, so even if we add those together, we get the same thing. Okay, so we're going to make the decision. We reject H of O at the 0.05 level. And our conclusion, since P is less than 0.0001, there is strong evidence of a linear relationship between fuel efficiency in miles per gallon and weight in thousands of pounds. Now I'm going to start talking about R squared and R. So I go to my data and look, there's R squared, so 75.6%. So R squared equals 75.6%. So 75.6% of the variation in miles per gallon, you could put as explained by the linear relationship with, I'll put that down, is explained. You could put by the variation in weight. You could put by the least squares regression line, but I'm going to put by the variation in weight. Now, if we take the square root of 75.6% and we do 0.756, and let's do that. So I'm going to do the square root of 0.756, and that's R. Now, remember, your scatter plot is negative, right? We got a negative scatter plot here. It's right there. So our value is going to be negative. So let's comment on that too. So R is negative 0.87, which is a fairly strong negative linear relationship between fuel efficiency and weight. And we're going to define what that relationship is when we do problem 11, which is the confidence interval for the slope. But that's it. So I think we covered all of our bases, and I think we've come out with a fairly strong conclusion here. Okay.